take a look at the concept of an infinite limit. As you can see here, we have the graph of the cosecant function. And if you wish to review your pre-calculus a little bit, the period of cosecant is normally 2 pi, so the period of cosecant of pi over 4x would actually end up being 8, which means that it takes 8 units horizontally for the graph to complete a cycle. And then we know that actually the symmetry of cosecant is such that you're going to have vertical asymptotes at the beginning and the ending of the cycle, and also in the middle of the cycle. And then you have these function value of a min of 1 halfway between the first two asymptotes, and a max of -1 halfway between the last two. So that's trigonometry that we can produce this graph. Now what I want you to notice is that if I approach, let's say for example 4 from the left, of this function, the y values actually get larger and larger and larger. So if I pick the x's close to 4 and look at the corresponding y's, those y's actually approach infinity. Now what I do want you to understand is that that means the limit does not exist. Infinity is not a finite number, but this is a way for us to say the limit doesn't exist because the function is unbounded or infinite. Notice if you approach 4 from the right, this particular function's graph, if I approach 4 from the right, the y's are getting smaller and smaller and smaller in the negative sense of things, or approaching negative infinity. Still, it is still proper to say does not exist. These are not finite numbers. But this is what we mean by an infinite limit. And when a function has an infinite limit, many times it is tied to a vertical asymptote. I mean, not always, but many times that is the case.